In 2016, a complex computer simulation at Caltech produced a result that was fundamentally broken and supposedly impossible according to our current physics models. Two astrophysicists were modeling the solar system edges, trying to prove distant asteroids move randomly, but the code kept crashing and refusing to randomize data. Instead of chaos, the model aligned every distant object into a tight, synchronized cluster, swinging out in the exact same direction with perfect mathematical lockstep. According to celestial mechanics, these objects should be scattered like dust, but the statistical probability of this clustering happening by chance is roughly 0.007%. In the rigid world of astrophysics, 1 in 15,000 is not a coincidence. It is hard evidence that something massive is hiding in the dark. It implies that a shepherd is out there. Something with 10 times the mass of Earth is dominating the gravitational landscape and pulling strings from deep space. So, we started hunting. And for 8 years, we pointed our most sensitive infrared telescopes, including the WISE surveyor at the predicted coordinates, to find it. We scanned for heat signatures and reflection, looking for the faintest glint of sunlight bouncing off ice or rock. But we found absolutely nothing but void. This leads us to a terrifying paradox keeping astronomers awake at night. Because the gravity is undeniable and ripping comets out of orbit, but the object is invisible. We are not looking for a planet that is merely hiding in the dark. We are looking for an object that effectively is the darkness itself. This is the story of the ghost in our solar system, and the new evidence suggesting it might not be a planet at all. To understand why this invisible anomaly is breaking modern astrophysics, we first have to understand the map we thought we had for the last century. The standard model of the solar system has always been relatively tidy, containing 4 terrestrial planets, 4 gas giants, and a donut-shaped ring of icy debris. Beyond Neptune, the model suggests a gradual fade into nothingness, leading eventually to the theoretical Oort cloud, which is a sphere of ice halfway to the next star. We grew arrogant with this map, assuming that anything large enough to matter would reflect sunlight, just like Pluto did when Clyde Tombaugh spotted it in 1930. We also assumed that since the sun is the dominant anchor, everything orbits relatively flat against the ecliptic plane in a predictable and orderly fashion. Enter Mike Brown, a professor of planetary astronomy at Caltech, who is famous, or perhaps infamous, as the man who killed Pluto and downgraded it. In the early 2000s, Brown and his team started finding objects that simply did not fit the map and challenged our perception of the outer system. They found Sedna, a dwarf planet with an orbit so absurdly elongated that it takes 11,400 years to circle the sun just once. Sedna was the first crack in the paradigm because it never comes close enough to Neptune to be affected by its gravity. Yet there it is. According to the standard model, Sedna should not be there. It is like finding a heavy rock floating 5 feet in the air with no strings attached. Konstantin Batygin, a brilliant theoretician, joined Brown to solve the Sedna problem, assuming it was a calculation error or perhaps a temporary glitch in the data. They assumed observational bias, meaning we were only finding these objects because we were looking in specific patches of sky where the light was favorable. They spent years trying to disprove the anomaly and trying to prove that the solar system was normal, but the math simply would not cooperate. Imagine spinning a roulette wheel and the ball lands on red 6 times in a row. You do not assume you are lucky, you assume it is rigged. Batygin realized the solar system is rigged because 6 other major objects were all pointing their perihelions in the exact same physical direction, against all odds. In 2016, they published their paper in the Astronomical Journal, simply titled, "Evidence for a Distant Giant Planet in the Solar System," which changed everything. They called it Planet 9, and predicted its mass would be 5 to 10 Earths orbiting 400 to 800 times further out than Earth. But they made one fatal assumption. They assumed it was a planet made of rock and gas, and that assumption is precisely why we have not found it. Once the paper dropped, the race was on, and this became the biggest astronomical treasure hunt since the discovery of Neptune in 1846. Every major observatory joined the hunt, because finding a new planet in our own backyard guarantees a Nobel Prize and immortality in the history books. The logic was simple. Because a planet with 10 times the mass of Earth retains heat from its formation and should glow brightly in infrared. NASA had already scanned the entire sky with the WISE surveyor, so astronomers combed back through the data looking for a specific moving heat signature. They were looking for moving dipoles, which are objects that shift position against the background stars over time, proving they are close to our system. They found plenty of brown dwarfs and asteroids light years away, but at the specific coordinates Batygin and Brown predicted, they found absolutely nothing but vacuum. For 3 years, the silence from the telescopes was deafening, and the lack of a visual confirmation gave ammunition to the critics who doubted the theory. A faction of the scientific community, led by the Outer Solar System Origins Survey, argued that the clustering wasn't real and was just a statistical illusion. They claimed we were suffering from observational bias, meaning we only saw a pattern because we were looking through a straw at a tiny slice. They argued that Batygin was seeing faces in the clouds, and that if you look for a pattern long enough, your brain will eventually manufacture one. For 3 years, this was the war between the believers and the skeptics, and it seemed like the skeptics were winning because the sky remained empty. The lack of visual confirmation was damning, because if a 10 Earth mass object was there, the Subaru telescope in Hawaii should have seen it instantly. But then the universe threw a massive curveball in 2019 when 2 physicists looked at a completely different data set from a different part of space. Jakob Schultz and James Unwin were not looking at the Kuiper belt. They were analyzing data from the optical gravitational lensing experiment, known as OGLE. Gravitational microlensing happens when a massive object passes between Earth and a distant star, bending the light and acting like a temporary cosmic magnifying glass. Schultz and Unwin noticed an excess of short-duration lensing events, basically stars flickering because something massive and invisible was passing right in front of them. These objects had roughly planetary mass, between 5 and 15 Earths, but they were not stars and they were not gas giants. They were dark matter. This is where the paradigm shattered, as they asked, what if Batygin and Brown are right about the gravity, but wrong about what makes it? What if Planet 9 is not a planet at all, but something far older and stranger that has been hiding in our system since the beginning? Their theory suggests that the object perturbing our solar system is a primordial black hole, a remnant from the very first second of the Big Bang. Unlike stellar black holes formed from dying stars, primordial black holes are incredibly dense pockets of matter that collapsed before the universe had time to cool. This is the technical depth you need to grasp, because a primordial black hole with the mass of 5 Earths would not be the size of a planet. Because black holes are infinitely dense, its event horizon, or Schwarzschild radius, would be roughly the size of a standard grapefruit you could hold in your hand. Think about that for a second. An object with 5 times the gravity of our entire planet crushed down into a sphere this incredibly small. This hypothesis explains everything perfectly. The gravity to shepherd Sedna, the invisibility due to lack of surface, and the lensing events seen in the OGLE data. We have not found the planet because we are looking for a mountain that reflects light, but we should be looking for a bullet hole in reality. This is not just theoretical physics anymore, because right now in Chile, the Vera Rubin Observatory is preparing to come online and settle this debate forever. It is conducting the legacy survey of space and time, and will photograph the entire available sky every few nights, creating a movie of the universe. If the Planet 9 object is a primordial black hole, the Rubin Observatory is our only chance to see it. But not by seeing the hole itself. We will see the destruction it causes, because even a grapefruit-sized black hole would interact violently with the diffuse matter floating in the Oort cloud. As this matter spirals into the event horizon, it heats up due to friction, creating distinct bursts of radiation, known to astronomers as accretion flares. These flares would not look like reflected sunlight. They would look like sparks in the dark, moving sparks that appear and vanish in mere seconds. We are programming our algorithms to look for these specific sparks because they are the only fingerprints a ghost leaves behind in the cold vacuum. But there is another way to find it. Because according to quantum mechanics, black holes are not truly black. They actually leak radiation over time. Stephen Hawking proved that black holes emit particles near the event horizon, a phenomenon now known as Hawking radiation, which glows in the gamma spectrum. A paper published on Archive in late 2023 proposed using the Fermi Gamma Ray Space Telescope to hunt for this specific moving gamma signature. We are currently recalibrating our sensors to filter out the background noise and listen specifically for the radioactive whisper of a primordial black hole. But identifying the object is only half the battle, because realizing what it actually is opens the door to a much darker existential implication. If our solar system captured a primordial black hole billions of years ago, it means we are technically living in a binary star system. We orbit the sun, but the sun and this black hole are locked in a slow cosmic dance, balancing each other across a vast distance. It is too far away to swallow Earth directly, but being safe from the hole itself does not mean we are safe from its gravity. The danger is gravitational perturbation, because the Oort cloud is a reservoir of billions of frozen comets waiting silently in the dark for a push. A massive object moving through this field acts like a spoon stirring a pot, destabilizing orbits and sending debris hurtling inward toward the inner system. This aligns suspiciously well with the Nemesis theory, which suggests that something triggers periodic comet showers and mass extinctions on Earth every 26 million years. Paleontologists have known for decades that extinction events are not random. They follow a cycle that matches the orbital period of this theoretical dark object. The asteroid that wiped out the dinosaurs might not have been a random accident. It might have been thrown at us by this invisible neighbor. Recent studies in the monthly notices of the Royal Astronomical Society suggest that the statistical alignment of these extinction craters is too high to ignore. If the object is real, and if it is a black hole, it is effectively a loaded gun pointed directly at the inner solar system. The terrifying part is that we do not know where it is in its orbit, meaning we do not know when the next barrage starts. We spend billions monitoring asteroids near Earth, but we have zero defense against a shotgun blast of comets coming from the edge of the system. We used to think the danger came from deep space, but the mechanism that threatens us might be a permanent resident of our own home. This realization is quietly driving a new space race to build detection systems that can see gravity instead of just relying on optical light telescopes. Quantum gravity sensors are being developed that can detect mass fluctuations in real time, potentially revealing the location of the object before it flares. Artificial intelligence is being trained on orbital data to simulate millions of years of gravity backwards to pinpoint exactly where the intruder is hiding now. It is a race against time, because if the object enters a dense region of the Oort cloud, we might see the warning signs too late. A comet shower would not look like a single asteroid impact. It would look like a rain of fire lasting for thousands of years. Civilization can survive a single impact, but we cannot survive a sustained bombardment, which is why finding this object is the highest priority in astronomy. History shows us that Earth has been reset before, and the crater records suggest that the trigger is cyclical, predictable, and currently due for return. Some theorists argue this is why space agencies are suddenly so interested in planetary defense and redirecting asteroids, despite no immediate threat being public. The DART mission, which crashed a probe into an asteroid, was a test run for a scenario where we have to deflect multiple incoming targets. As we stand on the brink of confirmation, we are forced to reconsider our place in a solar system that is far more crowded than believed. In 2025, the floodgates of data will open as the Rubin Observatory begins a 10-year survey to map the invisible architecture of space. Artificial intelligence will sift through petabytes of noise, looking for the specific gravitational ghost that has evaded human eyes for more than a century. We are also designing missions like Breakthrough Starshot, which aims to send nanocraft at relativistic speeds to chase down objects in the outer dark. If we confirm the location of the black hole, we could theoretically send a probe to orbit it, using it as a gravitational slingshot. This would be the holy grail of physics, allowing us to study the event horizon of a primordial object from close range for the first time. But until that day comes, we are left with the mathematical certainty that our map of the solar system is fundamentally incomplete and broken. As we prepare for the inevitable confirmation, here are the 3 critical realities you need to accept about the new shape of our home system. First, accept that we are likely living in a binary system orbiting a star of light and a hidden partner of shadow and gravity. Second, understand that the era of optical astronomy is ending, and we are entering the age of gravitational sensing, where mass is the only truth. Third, recognize that the greatest threat to life on Earth might not be a random rock, but a calculated cycle driven by our neighbor. We used to fear the dark because of what we imagined might be in it, monsters or gods that controlled our fate from the shadows. Now science is handing us a flashlight and telling us that the darkness itself has mass coordinates and a gravitational pull that shapes us. The question isn't whether something is out there. The question is, when it finally flares to life in our telescopes, what will we do? Will we see it as a new frontier for exploration, or will we realize it is a sleeping giant that is about to wake up? The universe is stranger than you think, and the things we cannot see are often far more important than the things we can. If you want to understand the physics of the invisible and stay ahead of the discoveries that are rewriting our reality, make sure you subscribe. The next paradigm shift is coming, and you do not want to be left in the dark when the lights finally go out.